Have you ever wondered why we earth electrical systems? Well, it's not just for fun or out of habit. Earthing, also known as grounding, is a crucial aspect of electrical systems, designed to ensure safety and proper functioning. This process involves creating a low-resistance path for electric current to flow into the ground when there's a fault or an abnormal condition. Think of it as a safety net, catching any excessive current that could pose a danger and diverting it safely into the ground. It's a bit like a bodyguard for your electrical system, stepping in to protect when things go awry. It's not just about protection, though. Earthing also plays a vital role in stabilizing voltages and ensuring that equipment operates within specified voltage limits. So, in essence, earthing is our first line of defense against electric shocks and electrical fires. Now let's delve into why earthing is so important in our electrical systems. Firstly, safety. Earthing is the unsung hero that keeps us safe from the perils of electric shocks. Picture this. There's a fault in your electrical system and suddenly there's a surge of current. Without earthing, this current could pose a serious danger to people and property. But with a well-structured earthing system, the excess current is directed safely into the ground, reducing the risk of shocks and even fire. Next, we have equipment protection. Electrical equipment, like any other machine, has its limits. Push it too hard and it might just break. That's where earthing comes in. It serves as a reference point, stabilizing voltages and ensuring that your equipment operates within its specified voltage limits. This prevents damage due to overvoltages and transient surges, extending the life of your equipment. Then there's the issue of static charge dissipation. Ever got a little shock when you touched a metal object? That's static electricity at work. In some industries, static electricity can pose a real hazard. Earthing plays a critical role here by dissipating these static charges that accumulate on equipment and surfaces, keeping the workplace safe. Finally, earthing helps reduce interference, specifically electromagnetic interference and radio frequency interference in electronic circuits. In our increasingly digital world, these interferences can wreak havoc on sensitive equipment. Earthing ensures that unwanted currents have a path to the ground, preventing them from causing disruptions. In a nutshell, earthing is like the silent guardian of our electrical systems. It safeguards us from electric shocks, protects our equipment, dissipates static charges, and minimizes interference. It's the invisible link that connects our electrical systems to the earth, providing a safe pathway for fault currents. Therefore, without effective earthing, our electrical systems would be far more dangerous and less reliable. Did you know that there are different types of earthing systems? Each one is designed to cater to a specific need, ensuring safety and stability in various situations. Let's start with functional earthing, also known as protective grounding. This process connects non-current carrying metallic parts of equipment to the ground. Picture a metal casing on a piece of machinery. It doesn't carry current, but if a fault happens, the current may pass through this casing. Functional earthing ensures that such stray currents have a safe path to the ground, thereby preventing electric shock. Next, we have equipment earthing. This is similar to functional earthing, but it specifically involves connecting the metallic body of electrical equipment to the ground. Think of a washing machine or a refrigerator. If an electrical fault occurs, equipment earthing ensures that the excessive current doesn't cause damage to the appliance or become a danger to people nearby. Then there's system or power earthing. This is where the neutral point of a power system is connected to the ground. In other words, it's about maintaining the system voltage within safe limits. It's like a balancing act, where the grounding helps keep the electrical system stable. This is especially crucial in power generation and distribution systems. Last but not least, we have lightning earthing. This one's pretty self-explanatory. It's all about protecting structures from lightning strikes. When a lightning bolt hits, it looks for the path of least resistance to the ground. Lightning earthing provides that path, allowing the intense current to dissipate safely into the ground, protecting the structure and its contents. Each of these earthing systems serves a unique purpose, and the choice of which to use depends on several factors. These include the nature of the installation, the type of equipment, and local regulations. So depending on the nature of the installation and the type of equipment, different earthing systems may be used. Understanding these differences and their applications is key to ensuring safety and efficiency in our electrical world. Proper design, installation, and maintenance of earthing systems are essential for their effectiveness. These elements are not just a matter of good engineering practice, but also a requirement by national and international standards. Organizations like the International Electrotechnical Commission, or IEC, and the National Electrical Code in the United States, known as the NEC, provide invaluable guidelines for earthing practices. These standards are developed by industry experts and serve as a roadmap for creating safe and effective earthing systems. They cover everything from the design and installation process to the maintenance and inspection of existing systems. The guidelines accommodate different applications and environments, ensuring that earthing practices are tailored to specific needs and circumstances. So, whether we're grounding a residential building, a factory, or a high-tech data center, these standards provide a framework to ensure safety, protect equipment, and maintain system stability. By adhering to these standards, we ensure that our earthing systems are as safe and effective as possible. To wrap up, earthing is a vital aspect of electrical systems that we cannot overlook. Its primary role is safety, creating a low-resistance path for electric current to flow into the ground, preventing electric shocks and reducing the risk of fires. Beyond safety, earthing protects our equipment. It stabilizes voltages, shields equipment from overvoltages and transient surges, and dissipates static charges. Also, it's crucial for reducing electromagnetic and radio frequency interference in electronic circuits. We've explored different types of earthing systems, including functional earthing, equipment earthing, system or power earthing, and lightning earthing. Each serves a unique purpose and is chosen based on factors like the nature of the installation, the type of equipment, and local regulations. Adherence to national and international standards, such as those set by the IEC and NEC, ensures the effectiveness of these systems. Remember, effective earthing is the key to safe and reliable electrical systems. So the next time you switch on a light or use an electrical appliance, spare a thought for the humble earth wire that keeps us all safe.